Okay. So once the this one they have been decided the planning, okay, then this information will be cascaded to the styling team also. That is one of the stakeholder. Okay. The styling team is the one first they are going to decide how the vehicle looks. Okay. So first they will create some initial sketch. Okay. The rough hand sketch they will do. And once it has been approved or selected by the styling team, then it will be they will do some scaled model. Then they will review with the management. Once this scaled model, several models they will make. Then they will select the theme. This area, this is good, this is bad. This needs to be improved. Like that, they will give suggestion. Finally, they will come with one solution. For that solution, they will make a full size scale model. Based on that, they will prepare the styling data. This styling data is the primary input for the design team. Okay, I have given some video for your reference. You can go through it. They will do a scaled model. Okay. These are the design sculptures who do the scaled model. This is the clay. With the help of this clay, they will build the scaled model. They will build the scaled model like this. Okay. 1:4 model or 1:6 model like that, they will make it. They will fix, okay, like this. Okay. Over that, they will do some aesthetic papers over that, and they will make a how does that vehicle looks in the road. Like that, they will make some concept.
Favorite part of that,
Okay.
once that happens, then it becomes open to opinion or change. Perhaps where the
Once they complete the scaled model, then they will scan it.
measurements are so important because they help us comprehend where the clay model is at in relationship to all the boundaries that we find in.
The scanned model, okay, that will be scanned. Then it will be take it as a cloud model. Then the cloud model they will post process, and they will make the CAD model for this one. They will do some analysis. Okay, how does it looks? Okay, all the analysis the styling team they will do internally. Okay, so wherever they have been found some issues for that model, then they will give the feedback. Since this is the clay, they will adjust this again. They will scan, and again they will post process this one. Okay. Then they will finalize, and they will make the full size model.
Like it for change yesterday. And we had two different project. I started by discontinued all the info for another display. It's really nice. I made like a piece of wood in a wall panel, or I'm walking.
Okay, so as of now, this is the styling data they will make. The aerodynamical and other stuff and all later on they will check it once they will do this one. Okay, so again, the packaging analysis and the aerodynamic analysis, this all comes under one by one, the stage by stage, they will check it once. Okay. This is the very initial care data they will prepare. Okay. The styling will keep on update based on all the requirement. Okay. They will share this to each and every team. Okay. The CA analysis team, the BAW trims design team. Okay. And manufacturing team, they all the team they will evaluate. Okay, they will do their study, they will give the feedback to the styling team. Again, based on the styling, it will keep on modifications. So in the industry they will have some milestone for the styling data. So when which kind of data has to come to engineering team? Okay, when engineering team has to provide the feedback, when is the next cut of data has to come? What are the informations this new styling data contains? All this they have some guidelines. Okay, so as I explained, okay, this is somewhat vast area. So when which activity has to come? Okay, just I give some overview for you. Okay, so the next step, okay, I will show some planning sheet for your reference so that you can understand even better. Some concept study model. Okay, for the new Nissan Rogue. Okay, so this is the planning paper issued to all the stakeholders. Okay, especially for the BAW designers. Here you see. So they have been launched the Rogue on 2013. Okay. Next, they have been launched the Rogue upgraded version of the Rogue Sport. That is on 2017. Okay. Next, they planning to launch a new Nissan Rogue on 2021. Okay. For the 2021 vehicle, the 2017 vehicle is the base vehicle. Okay, this is the base vehicle for us. This is the one we are going to design. This is just a rendering image for your reference. Okay. So this is already previously launched vehicle. This is the new generation vehicle we are going to design. Okay. For that, they have been designed the concept. Okay. A new vehicle has to look like this. They do the rendering image. Okay. They have been set to target to the BAW design team. Okay, especially in terms of mass, it has from the previous generation vehicle, we have to reduce by 5%. That is the target for the BAW design team. Compared to the previous generation vehicle, okay, the interior cabin size, okay, it is average. Okay, the next Nissan Rogue, they want to have a best in class. Okay, compared to the previous generation Rogue, more cabiness, more roominess they want. Okay, stiffness. Okay, I will show in the upcoming how much stiffness need to be improved, how much visibility criteria needs to be improved. The rear door opening area, okay, it is average one. They want to have more wider for easy entry and exit. We should have a better crash performance than the previous generation vehicle. Appearance wise, more sleek and more styled question that we have to follow. The aerodynamic, they have been set. Okay. So compared to the previous generation vehicle, the aerodynamical, okay, the CD value needs to be improved by 5%. All this are set as a target for the new vehicle. Okay. in the new vehicle, they are not defining the values. Okay, compared to the previous generation vehicle, how much needs to be improved? Always this targets against the previous generation vehicle only. From that, we need to improve from this lower value to higher value. Okay, so their design philosophy is overall dimension, the vehicle size need to be improved, crash performance need to be improved, stiffness to be improved, NVH performance to be improved. While improving all this, okay, so weight, okay, without compromising the weight, we have to improve all the performance. Okay, so we can improve this performance by adding few parts. Okay, we can easily achieve the this performance, but that directly affect the vehicle weight. That's the reason they are mentioning that increase all this thing without compromising the vehicle weight. These are the target set to the design team. Okay, so they have given the target. These are the test or the mandatory targets we have to achieve. Okay, this safety, NVH, ride and handling, those things I will explain in the next sessions. What is this? This OBD, FLP, SOL, what does it means? I will explain in the upcoming sessions. Okay, so they have been decided, okay, by reducing the mass, by improving the material selection. This material selection also I will explain what all the new materials they have been invented, how to reduce the vehicle weight, that I will explain to you in the next session. Okay, so the crash performance wise, we need to improve the frontal crash by 10% compared to the previous generation vehicle. We need to improve 10% of the uh, crash performance. Okay, the side crash performance need to be improved by 38%. Okay, the platform improvement, okay, for the offset oblique. Okay, this is the load path. The load path needs to be ensure more smoother load transfer. Okay, the stiffness improvement, the torsional stiffness need to be improved by 27. The lateral bending stiffness need to be improved by 17%. These are the target given to the BAW design team. Okay, so the roominess wise, okay, they have been set the target. Okay, the headroom need to be improved by 28%. The kneel room needs to be improved by 10 mm and 40 mm. Like this, they set the target to the design team. Okay, so what is torsional stiffness and the bending stiffness? Okay, that is a separate CAE topic. Okay, so not this session. Okay, I will explain in some other sessions. Okay, I will surely I will explain. Okay, so during the crash and the durability sessions, that I will explain what is other CAE requirement. That separate session I will explain to you. Okay. So once you receive these targets that has been set for the new vehicle, okay, next plan. Okay, so this is the advanced engineering study. Okay, what are the things I have been shown you? Okay, so this one, okay, the target has given to BAW team. Okay, For example, this is the frontal crash needs to be improved by 10%. Okay, that is my target. Okay, so here these all the parts are affecting by the frontal crash. Okay, so if you withstand 10% more load, what I have to do? I have to either improve my design. Okay, I have to add some more reinforcement to the structure, or I have to select alternative material. The high strength material I have to select. Okay, so either I have to change my design, I have to add some reinforcement, or I have to change the material from low strength to high strength, so that these parts, if I change the design or material or add some part, I can withstand more than 10% of the crash load. The same way here. Okay, these are the parts affected by the side crash. Okay, for this, more than almost 40% of the load, it has to additionally withstand. How? I have to add one more reinforcement. I will change the lower strength material to higher strength material, so that I can withstand more load. Okay, so in this case, okay, so first we have to get the basic information from the previous generation vehicle. Okay, the previous generation vehicle, okay, this area, this is the load path area. Okay, for example, this part, okay, they have been selected 440 megapascal steel. This megapascal steel I will explain to you. Okay, this is 440 megapascal strength. I change to 780 megapascal. This is medium strength. This is high strength. So I am improving the material grade for this part. This part, A pillar inner, this is 590 megapascal. Instead of that, I am moving to 980 megapascal. Okay, so that this is moderate strength material. This is high strength material. So this platform structure withstand more load compared to the this one. This is very high strength. This is moderate strength. So this structure withstand more load compared to this structure. The same way, I will show. So this is the new Volvo structure. Okay. This area, they have been used the low strength material. Okay. This area, they have been used the high strength material. Okay. Compared to this area, this gray means low strength material. Okay. Blue, it is moderate. Yellow, high strength. Red, ultra high strength. See, this area, they have been selected yellow, that has been changed to red in order to withstand the better side crash performance. This area, it is made up of moderate or the high strength steel. That has been previously, it is moderate strength. So these are the material distribution chart. Okay. From the lower grade to higher grade, if we change, the vehicle structure can withstand more load. Here you can see this is made up of high strength material that turned into ultra high strength material. Okay, this is advanced high strength material that turn into ultra high strength material. This area they have been used only 7% of the hard stamped part. This area 38% of the hard stamped parts they have been used. So this is the previous generation vehicle. This is the new generation vehicle. From this each and every part, okay, what are the new proposal that will be captured. Okay, this kind of chart or the document they will make in the advanced engineering study. Okay, how they decide the material change. It is all based on the planning sheet. Okay, so in order to meet this target, okay, the crash target, okay, they are changing the material. In order to meet the stiffness requirement, they are changing the material or they are adding some more part or changing the design. Okay, so the next stage is, okay, from the base vehicle, what all the changes that we are going to do that will be captured. That is called as a design concept sheet. Okay, this is the sample of the design concept. From this, okay, I am changing this material to this material. This part, I am changing this grade of material to this grade of material. This area, I am planning to add one reinforcement. Here, I am deleting one part, not only adding. For example, for some requirement, we may not have required that kind of part. You can even delete some parts. Okay. So the modification from the existing vehicle to the new vehicle, okay, that will be captured in the design concept sheet. Okay. Until now, what are the things I have been explained to? Is that clear?
Yes, sir.
Okay. So the next thing is, okay, so preparation of RFQ, that is request for quotation. Okay. So in this, I am planning to change this material to this material. That means 7% of hard stamp parts to 38% of hard stamp parts. Okay. Cost wise, okay, this is low cost. Keep on increase the cost. Same way here too. Okay. So the low strength material, the cost will be very low. If you keep on increasing the strength, the cost also keep on increase. Okay. Here you use only 7% of the parts with ultra high strength. This is a hard stamped part. Here 38%. Okay. So when you are migrating from lower strength to high strength, the cost also will get increase. Okay, so this most of these parts are come from supplier, because we will design the component and we will share it with the supplier. They will do all the formability analysis and the tooling. Everything will be done at supplier end. Okay, they will do the feasibility and they will decide whether this is possible or not possible. If you are migrating this much cost will be impact. Okay, all the details will be prepared by the supplier. Sorry, any doubt? Okay, so once this design concept has been freezed, we need to share our new proposals to the supplier. We will ask the quotation in order to manufacture this part. Okay, how much you are quoting? Okay, how much cost you will you need in order to make single component? The tooling cost, the part pricing cost. Okay, the raw material procurement cost, all the costs they will do, and they will fix the final price of each and every part. Okay, that will be a discussion between our OEM, that means the automotive company, to supplier company. Once this activity has been completed, okay, next is the physical confirmation study. Okay, in this physical confirmation study, what they do, okay, so they will, for example, for the crash test, differential crash test, okay, this 1, 2, 3, 4, 5, 6. 6 spots are majorly getting impact through the front structure, for example. Okay, here around 10 parts are getting changed. Okay, so now you are proposing this area. This part needs to be changed by this one. You are proposing 590 megapascal to 980 megapascal. This area 440 megapascal to 590 megapascal. How to ensure your new proposal will work or not? For that, what they will do, they will take the previous, because we didn't start our new vehicle design, right? Hello, guys. So this, they will get the old vehicle. That means the previous generation Rogue. They will get it. Okay, they will make, okay, these components with the higher grade material by using proto method. Proto method means they will do only few components with the higher grade material. They will take it out, these parts from the old vehicle. They will cut it physically. They will cut the parts from the old BAW structure. They will make few parts. Okay, this parts. Okay, they will make by using prototype method with higher strength material. Then they will fix it and they will weld it. Okay, they manually weld in this area. Okay, basically they are replacing the old vehicle parts with the upgraded parts. Okay, and they will fix it. Then they will do the crash test. Okay, compared to the previous generation crash test, whether the 10% improve or not improve, they will check it. This process is clear? Hello?
Yes, sir.
Okay. So physically, they take the older vehicle, they do tear down, they will cut the part, they will remove it, they will replace the part with the high strength material. Again, they will fit with the help of welding process. Then they will do crash simulation. They compare the result, okay, with the low grade material, what is the crash test? With the replaced material, what is the crash test? Okay, if they satisfied, okay, then okay, so they will go ahead. Okay, so our plan may work for the new vehicle. They will get some conclusion. This activity is called as a physical confirmation study. Yes, they will do all the prototype model only. They will not make a full-size model. Approximate model, they will do it, okay, with not much holes or not much emboss. They will do some basic shape. Just with the help of the proto method, they will make the part. They will physically fit into the vehicle. So not a complicated design. Okay, approximate design of that part, they will just fit by using proto method. Just this is not a production vehicle. This is a testing vehicle. So they will not do all the kind of stuff. They will do some proto model. Okay, so once for the new vehicle, they have been concluded, the crash, component test, durability test, all these tests are passed. Then they will go for the actual CAD design. Okay. In the next session, I will explain step-by-step procedure of the CAD activity.